Hi guys, and welcome to a new video. In this video I would like to solve a math problem, a geometrical problem. So in this problem we have basically a semi-circumference, so I'm going to draw it. Okay, so more or less this is our semi-circumference. And we have points A and B, so we know that the length of AB will be 2 times R. Okay, so we have to consider 2 points belonging to the semicircumference P and Q. So we have to consider these 2 points Q and P. Okay, P and Q are such that A, B, P is equal to X, so the angle ABP. So I'm going to draw this side and this side is X, so BBQ is pi over 6. So I'm going to draw all these lines, and I'm going also to consider OP. So the idea is to call ABP X, so this angle is X, and we also know that PBQ is pi over X over 6. So we have to find X such that the area of the triangle APQ is equal to 2 times the area of BOP. Okay, so this is our problem. The idea is to, first of all, to consider these 2 terms, so we have somehow to express these 2 areas in terms of X, and then to solve the equation. So I'm going to start with the triangle BOP. So we know that the triangle BOP is this one, and we have X, we have R and R here, so it means that this angle is equal to this angle, so we have X and X here. So that means that the angle, the triangle BOP is more or less this, and we have X, X, R and R. So the area of this triangle will be F times the basis over 2, where we have H and this is B. Okay, so we know that, for example, the F will be R times sine of X. We have H, R and X here, so this means that H is R times sine of X. And we also know that P over 2, so this side will be R times cosine of X. Okay, so that means that the area will be R squared sine of X times cosine of X. And we can also express this this product considering 1 over 2 R squared sine of 2x. Okay, so this is our first result. The area of the triangle BOP consider the fact that given a triangle, the area of the triangle is basically the product between the product of two sides and times multiplied by the sine of the angle between these two sides divided by 2. So that means that here, for example, we can consider this angle, which I will call, for example, y, and we can consider this side and this side. Okay, so now we have basically to find the angle y and these two sides. So I think that I'm going to start with the angle y. So we have that, for example, this little angle is pi over 6, and we know that, for example, this angle is 90 degrees and also this angle is 90 degrees because it's a triangle inside a semicircumference. So this is 90 degrees and this is 90 degrees. We know that if this small angle is pi over 6, which is 30 degrees, this angle will be 60 degrees. So this angle will be 60 degrees and this angle will be 60 degrees as well. So that means that y will be 30 degrees, which is pi over 6 as this one. Okay, so y is 30 degrees, and we know that the sine of 30 degrees is just 0.5. Now we have to consider AQ and AP. We know that AP is the side of this triangle, and we know that this side is just 2r, which is the diameter, and AQ is the side of this triangle, which is again a triangle with 90 degrees here. Okay, so that means that, for example, AP will be sine of x times 2r. Okay, so 2r sine of x, and AQ will be 2r times sine of x minus pi over 6, because we know that AQ is this one, so we have to consider this angle, but this angle is x minus pi over 6. So that means that this side will be sine of this angle times this 2r. Okay, and as we said, the area of this triangle can be determined by this product over 2 times the sine of y, which is 30 degrees, pi over 6. So we have just to put in these two values inside this formula, and we get 1 over 2 times 2r sine of x, 2r sine of x minus pi over 6, and then we have also sine of 30 degrees, which is 1 over 2, so here we end up with 1 over 4. Okay, so we found also the second term of our equation, that the area again of APQ is 2 times the area of BOP. But as we said, APQ, the area of this one, is 1 over 4 times 2r sine of x times 2r sine of x minus pi over 6. Okay, and this is equal to 2 times with respect to x. So first of all, we can consider this is 2, and this also goes, this go away. We have r over our r squared, and here we have r and r. Okay, we have also these 2 and these 2. Okay, so basically we end up with sine of x times sine of x minus pi over 6, which is equal to sine of 2x. Okay, now we can consider the fact that this can be written as sine of x times cosine of pi over 6 minus cosine of x times sine of pi over 6. Okay, so we can write this, and this means that here, for example, we get sine of x, and here cosine of pi over 6 is 3 under square root over 2 times sine of x, okay, minus 1/2 cosine of x, and this is this first term on the left will be equal to sine of 2x. Okay, and now we can consider the fact that sine again of 2x is sine of x times cosine of x. So we can write this one times sine of x cosine of x. Okay, so as we said, we end up with 3 under square root sine of x squared minus 1/2 sine of x times cosine of x equal to we had sine of 2x, which can be written as 2 times sine of x times cosine of x. Okay, but now if we say that sine of x is different from 0, which means that x is different from k times pi with k, which is an integer, so 0 plus or minus 1 plus or minus 2. So that means that basically here we can cancel sine of x here and here and here. So we end up with 3 under square root over 2 sine of x minus 1/2 cosine of x equal to 2 cosine of x. And now we can also say that if cosine of x is different from 0, which means that x is different from k, well, we can say just k times pi over 2, because we know that x is different from, has to be different from k times pi, and cosine of x is different from 0, so we end up just with this condition. We know that here we can cancel cosine and cosine, and we end up with sine over cosine, which is tangent. So we end up with 3 under square root tangent of x minus 1/2 equal to 2. Okay, so we end up with this one. We can also multiply it by 2, and we end up with 3 under square root tangent of x minus 1 equal to 4, and this means tangent of x is equal to 5 over 3 under square root, or if you want, 5 times 3 under square root over 3. And this means that x is equal to tangent to the minus 1 of this number, which is